Thank you so much. Good evening to all of you. And this is my project, Python Power Electronics. And essentially, it's an open source circuit simulator in Python. So it's a lightning fast talk, so I'll go lightning fast. And a brief background is my own background is I'm an electrical engineer. And as an electrical engineer, I need to simulate very large electrical systems with power electronic components. Example is, let's say, a wind farm with 25 wind turbines. And you might want to simulate exactly what happens with changing atmospheric conditions, changing wind speed, wind gusts, and so on and so forth. So for this, I have a project homepage. It's on SourceForge. A lot of people have told me to move on to GitHub, and I'm beginning to see the wisdom of that. I probably will do so. I have a blog about the project. It's on Blogspot, and I describe what I'm doing and why am I doing it, and sometimes also talk about the errors I made and so on and so forth. The status of the project is I've released around 8 versions so far. A basic simulator is working with a basic electrical library. So I'll talk about the user interface. I can't go through the code right now, but I'll be talking to anyone who wants to know about it. Now, there is no GUI. There's no graphical user interface. The entire user interface is through spreadsheets. So ideally, if you want to describe a circuit, you have to describe it using a spreadsheet. I've used Microsoft Excel and also OpenOffice. They work OK. You need to save it as a comma-separated variable file. So this is an example circuit. If you are familiar with electronics, you'll know this is single-phase diode bridge rectifier. Okay? So the idea behind this is you can actually not code. A user can just describe the circuit with almost something which is visual. So an example is, let's say, resistor R1. Okay, that's a particular resistor. This can be broken into 3 parts. First is resistor, which is the actual name of the object. Here is the name of the device. The underscore is the differentiator. So that's you can't use the underscore in the name. It's a reserved character. And the last is R1, which is the name of the resistor. So here there are some rules. You can't name 2 resistors with the same name and so on and so forth. So in this way, I have a certain library. There is a resistor, inductor, capacitor, voltage source, current source, ammeter, voltmeter, diode. This is what works so far. And I'll continue with the user interface. Once you describe the circuit, and once you execute it, it'll automatically take all the elements it has found, and it'll ask you to enter variables to it, as in how it feels. Some of them will have default parameters, and you can change them. There are also certain things, for example, certain devices have polarities, and you need to change those polarities as in how you need to enter them. Once you execute the file, it'll store the final data. All the data is in the form of variables which are measured through meters. So it's like ammeters, voltmeters, and so on and so forth. And the data, the first column of the data is the time. The others are the actual variables. So you can plot it using GNU plot or any other plotting software. I usually use GNU plot, but you can also use certain plots like transplot and others. So now the future work is, now that this basic library is up, I need to now build on power electronic components. I need to build on things like IGBTs, GTOs. Later will come a machines library. That's like induction machines, synchronous machines. And since I work in the field of renewable energy, I will also be building a renewable energy source. That's like photovoltaics, wind turbines, so on and so forth. And the main reason for choosing Python was I want to integrate this with other scientific projects. Like, for example, there are other stuff happening in Python based on signal processing, linear algebra, controls. And I would like to create a kind of an ecosystem on that where you can do simulations in electrical engineering and also do other scientific applications which are based on Python. So with this, it's more or less, I'm done with my presentation. And thank you very much.
We have a couple of minutes for questions. 2 minutes for questions. Anyone wants to come up? Okay, I've got a question, Chief. Okay, what made you get this idea? Where did this come from?
It's like this. I usually use things like MATLAB for simulations. And one of the problems with using MATLAB is when you have a very large simulation, for example, like you have 25 wind turbines, and you want to simulate this, let's say, for 24 hours, you can't do it in MATLAB. Quite often, it'll just hang, it'll crash. I mean, I know there's a code of conduct, and I should say anything negative, but in general, many of these softwares are good for dealing with small circuits. But once you have a very large circuit, it just won't work. So, which is why I wanted to go away from GUI and away from heavy systems. I did everything in C++, but it was actual code. So I wanted to create a framework where more or less everything is automatic. So I chose Python because it's used by the scientific community. And I don't know if I'm right or wrong.
Just a follow-up question really quick. How is this applied? Did you use this in the real world? Did you actually use this after your simulation?
No, it's, see, basically, my simulations, which are in C++, is how I got my PhD. So yes, they didn't work. The ones which I'm doing in Python is essentially working so far, but at a very basic level. Like I said, it's a very basic electrical library that's up. But you can simulate circuits with that. So it is working. The next step is, of course, to actually build up objects which you can really use. That is in industry, machines and stuff like that. So that's upcoming. Thank you.